Hi everyone, and welcome back to the second installment of Airplanes in 3D, modeling the Republic F-84 Thunderjet. This week, we're going to be focusing on modeling the wings and stabilizers for the plane using splines, shape merges, extrusions, and the symmetry modifier. So let's get cracking. Have you been looking at or working on your fuselage model since the last time we met? I have, a little bit. I was doing a little bit of scale work on it to more closely match our diagram, and I think I've hit that point. It's not absolutely perfect, but it just has to be good. It just has to look like it. That's in general, I believe it does. At this point. They're doing a test render of the side of the plane, and looks like it's matching up pretty closely to our reference diagram here. So I'm fairly happy with it at this point. So the first thing we're going to do is we're going to create a basic intake and a basic exhaust. And they don't really get much more basic than this plane. they're circles, front and back. And what we want to do is select the polygon, the big round polygon that's going to make up our intake, and we're going to extrude that. Now at first, this is going to want to extrude outward. It's going to want to extrude forward of the fuselage, and we don't really want that. We want to draw that back inside the plane, so it's an intake and not an outtake. I guess it's an outtake, but we want that to be an intake, and that's as much as we're going to do on that part of it. We're not going to take it any farther inside the plane. We're going to have to move it forward anyway. Now we're going to later when we add the cockpit, we're going to chamfer some edges now and scale and shape those to create a sort of a bullnose effect for the front of our very front of our intake. And we're going to do that so that it's not just a sharp edge. It's going to be a rounded nose to the intake and look more like the actual aircraft, which did not have a sharp edge to the intake. It was a little more of a bullnose effect where it had some roundness to it and had some shape to it. So that's exactly what we're going to do here. This seems like it's a little tedious. Maybe it is. I don't know. There is a lot of edge and polygon selecting involved, making minor movements, minor adjustments to things so that they look like, or they fit our diagram a little bit better. Such as this, we're going to move these polygons up to the edge of that diagram and scale those just a little bit so that it more closely matches the diagram. There we go. And then we're going to end up selecting edges again. Once we've finished with that, we're going to select edges again, and we're going to select that middle ring of edges on the nose. We're going to move that out. We chamfered that at first, so we have those edges, and now we're going to move those out, and we're creating that bullnose effect, that rounded nose effect, and we're going to go ahead and chamfer that once again. We may make a couple of adjustments here and there, but we're going to chamfer that once again. Right now we're selecting way too many edges, and there's really no need for that. So we've got our edges here that we wanted to select. We might scale those, move them around just a little bit, but we need to chamfer some more edges to make that a little more rounded. So here we've got a selection of edges, and we can chamfer those. Again, we can move them around. We can chamfer those. We're going to select this middle ring of edges though, because that's the one we're going to chamfer. So maybe not quite that much, but some. And we're going to adjust this so that it gives us a little more of that bullnose effect that we're looking for. We're going to probably end up moving, one of the edge rings or ring of edges or however you want to put it back. We might scale it up just a little bit, and to give us the right shape. We're going to get it closer to the shape that we want, and close. It doesn't have to be perfect. It just we do, but we do want it to be close. We should go ahead and save that. We should go ahead and say OK and save that. We'll select this ring. Probably move that back just a little bit. As you can see, we switched from see-through to more solid looking model there, and it kind of makes it easier for us to see that a little bit. We're going to scale that up just a touch, and so we can, when we apply a smoothing group to it, we can trick the eye into making that look like it's just perfectly smooth, perfectly rounded, even though it's made up of several different segments. So here we are, and that's exactly what we're going to do. We're going to clear all of the smoothing groups that the program applied. We're going to select our own, and we're going to select one that matches the exterior of the fuselage there. And so they'll all be the same smoothing group, and it'll look very nice and round, as you can see in this test render. In the test render, you can see that the nose of that intake, looks pretty round. It looks pretty rounded. You can't see any of the segments at all. And we could talk about level of detail right here, and how much detail you want to put into something like that. Here we're selecting, and we're going to hide the front view pane, and we're going to get into making the jet exhaust. We're selecting the polygon again for the exhaust. We're going to select the edges, the ring of edges that make up the exhaust, and we're going to chamfer that just a little bit so it gives it a bit of an edge. And then we're going to go ahead and extrude the exhaust inward toward the inside of the plane. But I was talking about level of detail, and generally, I mean, when I'm composing a scene, the planes that I do a scene with, the virtual camera can be, a couple hundred feet away at least from the aircraft, not necessarily right up on it, and so, do I need an extreme level of detail where the model is just has like just tons of polygons, and no, not necessarily. I mean, the model needs what it needs. It needs enough, so that it looks nice from a reasonable distance, and so that's, after a few years, I've learned that we can do that and be successful. And so now we're going to make a wing. After you saw the extrusion inward for the exhaust, so now we're going to make a wing, and we're going to do that first by creating a spline. We're going to create an elliptical spline, and that's going to be, at first, that's going to be the closest to the shape that we would want for a wing root, for the core of a wing root here. And we're going to do an edge. We're going to pull that out from the edge of the of the spline is how we're going to orient that to start off with, and then position that to where it's close to the drawing, and then we're going to turn that into an editable spline. As you can see, it has vertices, and you're going to see that there are little green boxes connected to the vertices by yellow lines, and you can drag those points, and so that you can control the curvature of the spline. We won't do that right now. We won't really need to. You can also scale those so that you don't have to move them. You can scale those an exact amount. If you have two of them, you need an exact amount scaled for both, and you can do that. We're just going to move them right now, so we don't really need to do a lot of scaling with them individually. But we can move them, and in this case, we want to move them so that they are, pretty close to laying out in the outline of our drawing, for our wing root. And let's focus here on really how many segments or sides we want this ellipse to have, and we don't need a crazy amount. We don't need a lot, because the more sides or segments you have, the more cleaning up you're going to have to do after you do the shape merge. And you'll see that part when it comes along. We'll have to target weld some vertices, some extra vertices that are created by the shape merge process. It's not hard. It's just at all. It's just something that you have to do, so that we don't have a lot of crazy edges, afterwards, and it just makes things tidier that way. So we've made adjustments to our spline, and let's name it something really unique and crazy. Let's name it something like wing root spline. So having done that, let's move it. Let's move it to the exterior of the fuselage, because where it was at on the inside would not work at all for our shape merge exercise here. It would imprint on the other side or not at all, and it wouldn't help us out in one bit. So let's go ahead and select shape merge, and then we're going to select the ellipse spline, I'm going to add that shape, and it is going to imprint that shape on the side of our fuselage. And now we're going to go to the Edit Poly modifier so we can clean up those extra vertices that are created, and you'll see them. I mean, obviously you can see them now, but I left the shape of the ellipse spline because it's easier to do this, and you want to maintain the shape of that spline that you used in the shape merge, unless there's a reason not to. And what we're going to do now is we're going to cut edges in between all of the vertices, top and bottom, for the wing root, and we're going to get rid of the extra ones by target welding some vertices together. It's probably not going to be apparent why right now, but in our next installment, when we actually make the wingtips, it will be. So now we're going to select the polygon that was created by the shape merge. And we're going to want to extrude that away from our fuselage. We need the front view, which we're looking at from the rear. We have to make that the front view. There we go. And now we need to extrude that at least part way from the fuselage. I'm not going to take it all the way out because it's not really necessary. We can extrude it just a third of the way, let's say, and be done with it, and we can move we can move everything toward the wing tank or the wingtip later. So having done that, we can go ahead and accept that, and we can move this toward where the wing would end at the wing tank right here. Now we're not going to get to the wing tank this week. We're going to do that on the next installment. It's not very difficult, but we'll put it in with the making the wing tips and the tips for the horizontal stabilizers. I've just made that planar in the x axis, and now we're scaling that to sort of fit the diagram there. And we're going to end up moving that. We're going to end up scaling it again in the y-axis on top to make it fit more closely to that part of the diagram. And yeah, we're real close to that. We're not going to go crazy with it, but we're pretty close to that right now. And we're going to push that back. We're going to move that back to the root of the wingtip. And I think for now that's all we're going to do with that wingtip right now. There is one more thing that we should do to the wing, and a couple more things for this part anyway. And we're going to select all the polygons that make up the wing, top and bottom, and we're going to give it its own smoothing group number, but that's after we cut your nice plane in half and learn how to use the symmetry modifier, which is really simple. I mean, it's really easy, but it is so neat because all you have to do is select half the polygons on your model and then delete them. That seems like a big step, so you might want to go ahead and save the model, put a hold on it, and save it before we do this if you're at all nervous about it. But we collapsed that stack because we were still in edit poly mode, and we collapsed that stack, and now we're editing or using the symmetry modifier in the x-axis, and it creates the starboard side of the plane where we only left the port side. But now anything you do on the port side of the plane is going to be mirrored at the same time on the starboard side of the plane. This is a great tool. If you haven't used it before, it's a fantastic tool. So we're going to get rid of that cage that 3ds Max likes to give us for some reason after we collapse and do anything within symmetry. But it's a wonderful tool because most aircraft are symmetrical, with the exception of a few that we saw designs for toward the end of World War II from the Germans. The majority of them are pretty symmetrical, like the F-94 here. So this is a fantastic tool, and it saves a lot of time and headache as far as modeling these planes are concerned. So what are we going to do? We're going to select all the polygons top and bottom for the wing, and we are going to assign it a unique smoothing group number that's unique from the rest of the fuselage. You can let the program assign these sometimes, and it might not be the correct one, and your render could end up looking a little goofy. I just prefer manually assigning them, and I'm far happier doing that. Now we're going to use slice plane, and we can slice through all of our polygons. And what I want to do is there is a curvature at the root of the wing, at the trailing edge of the wing, and it curves from the fuselage to the trailing edge of the wing, and I want to be able to create that. So here we go. We got the slice plane moved into place, and really at this point all we have to do is click slice, and that will create a new edge all the way around our wing. And with that, it will also create a a couple new vertices. And what we need to do is we need to pull those forward. And so we have the basic spot where that, I don't know what you want to call it. You call it a fillet, I suppose, from the wing to the trailing edge of the wing to the fuselage. And we're going to fully define that curved shape later when we attend to some of the smaller details on the fuselage. Now we're going to make a vertical stabilizer, and we're going to cut a lot of edges. We're going to extrude polygons, and we're going to shape the thing with by cutting edges and pulling and scaling and doing all those fun things to vertices. So here we're selecting edges along the top of the fuselage where the vertical stabilizer lives. And we just specifically want to select the edges on top, and then what we are going to do is we're going to chamfer those edges to the width of the vertical stabilizer. So we'll have to use our connect modifier that's in the stack for manipulating the edges. Modifier, tool, I guess either word's appropriate, but that's what we're going to use. We're going to use the connect edges tool, and you can slide those new edges to the width or the approximate width of the stabilizer, and we're going to need to make this see-through now, and so we do. And so there it's pretty close. We'll try to get it just a little closer, but to start off with, it's already fairly close. So we don't have to really do too much more with it before we can go ahead and accept that and close the tool and move on. There we go. And so we're going to switch to vertex mode, and we're going to take a look at the very front of where our stabilizer is going to live, and we're going to target weld that front vertex to the center one on top. And there we go. So why did we do that? Well, we did that so we could create the tip of the leading edge of that vertical stabilizer. And we're going to be doing a lot of edge cutting and vertex moving, to make the shape a little closer to what's in the diagram. But we're starting off from a really good point. So here we're going to go ahead and cut a couple of edges where we're just cutting them in using a vertex cut tool, and we're gonna move those a little bit so we can get a little bit of a less pointy, more rounded, a little more rounded shape to the very front of the stabilizer. And we'll cut another edge here using the cut tool, and we'll move that vertex as well. Just move it down. We'll give it a little more definition there. Now we can make this as detailed as we want to. We can make this as well defined as we want to. Again, remembering that we may only be looking at this from 100 to 200 feet away. Your virtual camera is probably never going to be fully focused right on the tip of that stabilizer. So it's up to you really to decide how refined you want that shape to be. Now, after we get the general shape of our wings and wingtips and horizontal stabilizers and vertical stabilizers and the wing and the tips of those, then we're going to come back and we're going to do some more detailing work. Right now, we're going to extrude polygons. We've selected polygons. We're going to extrude them, and so we can begin creating our vertical stabilizer. And you're going to notice something that funny that happens when we extrude things. There we go. When we extrude things in symmetry mode, it doesn't extrude straight up and in one piece. It extrudes it in a V shape in two pieces. So let's drop that down just a little bit. Let's drop the height of it just a little bit, and we'll go ahead and select OK on that. We'll close that tool out, and then we need to delete the interior polygons, because you see it made polygons. It didn't just make it open, it made it closed. And so we need to delete those polygons, and we're going to select. This would be okay if it was a bonanza, if it was a beach bonanza, but it's not. So we can select the top row of vertices. We can select all of the top row of the vertices. There we go, and then we can move these together. We can in symmetry mode we can essentially glue these together without having to weld or anything like that, and that's just how it works. And so now we have one piece. It's in one piece now, and we're going to go to the back of it. We're going to select 3 vertices. We're going to zero that out and make them level, and we're going to scale them to approximately fit our diagram. And from here on out, it's moving things and scaling things and champering and a lot of it to get to our final shape. So it's real close at this point as far as that particular part of the shape is concerned. We're going to move it down somewhat to that panel line right there. And we'll be making further adjustments as we go along, obviously. But right now we're just trying to get a general shape. And so let's select that one. Let's bring it back a little bit, and then let's bring that one down. And we're going to zoom in. We're going to get it to line up with the bottom vertex. So those are all kind of lined up. There we go. Not exactly looking for precise, but close. Get it close, And so we've selected that edge or those edges, and now we're going to use the connect tool. And we're going to make an edge that runs across those 3, and that's going to be the basis for the fillet or the curved portion at the bottom of that stabilizer, at the base of that stabilizer. We're going to come back and further refine that in just a minute or so, just a few minutes. Right now we're just going to try to get the rest of them, as close as possible, Bearing in mind that our drawings, while they, in general, they're matching up pretty good. Enough for us to go ahead and work. The drawings are not, they don't match up one-to-one exactly. Most of them really don't, So you have to make some choices, and we chose to do a target weld on the tip of the stabilizer right there. And now we're drawing vertices backwards. We're pulling them back or down so that we can begin forming a leading edge shape, a rounded leading edge shape for the vertical stabilizer. I'm going to pull that back, and for the same reason, we need something where we can start creating a vertical or a rounded shape, and for the leading edge of that thing, and which we'll do by chamfering edges. Again, that's just the easiest way to do it, at least that I can think of. And you might develop your own. You might develop your own way to do it. I don't know. If you don't already have one. So here we've selected the center vertices, and we're going to go ahead and move those, draw those up, and we want them to touch the approximately the edges of the of our drawing. Looks good right there, and we can go ahead and pull that one back down. Great. So now we have something that just doesn't remotely even look like what it should. But give it a couple minutes. What we're going to do is we're going to start cutting some edges into the top of this thing. And when we cut those edges, you'll be able to see how it really takes on more of the shape, the correct shape of the stabilizer. So we're going to go back into edge. Are we going to go back into edge mode? Maybe not. Maybe we will. I don't know. We're going to do some cutting. We're going to cut some edges. We're going to cut some edges, and this is going to give us this is going to create more definition for the stabilizer. And now we're going to get rid of we're going to hide the front view plane, and we have to be able to work on the back of the stabilizer. So we are going to target weld some vertices, the top one, and then we're going to have to do some work on the bottom ones as well, so that doesn't look crazy and inappropriate. So we cut one lengthwise down the length of the stabilizer. Overdid it just a little bit. Gonna have to target weld on that, and gonna have to make another cut, and because we've got a kind of a crazy little edge going on there, so we're going to get rid of that by cutting in an edge and welding it. There we go. That looks better. And we're going to target weld there. So turn our edge, and we can talk about turning edges later as we need to, but awfully handy to be able to turn edges, because otherwise that would have just been a hole. That happens sometimes when you're creating new edges and cutting them and welding things together. Sometimes you can get a little error with an edge where you doesn't really appear like there's a polygon there at all. There is. You just have to turn the edge. and we can go into that, maybe in our next installment. So what we're going to do now is we're chamfering edges at the base of the stabilizer to get that curved area right there, and just going to play with some settings here. We're going to get the shape that we really want out of this. Selecting the vertices, we're going to go ahead and move those so that they're a lot closer to our drawing, the shape in our drawing, and then we're going to chamfer those again and really get it close. Now you'll notice that's going to create a lot of extra vertices. We're going to deal with that. We're going to go ahead and target weld a lot of those away because we just won't need them. We're going to go ahead and move this down and start shaping this a little bit more. And I hope you're going on the internet and you're downloading reference photographs. I've got a lot of reference photographs of my own after going to the National Museum of the U.S. Air Force, Pima Air Museum. I've got a lot of reference photos of the F-84 as well as other aircraft that I use whenever I model, that help me see past the reference drawings and get a better take on what the shapes are actually doing and how they're going together. Now, when that fails, then I have model kits, styrene plastic model kits, and I can reference those. And I have one of the F-84 G that I haven't even opened in 1/32 scale. That would make a good reference for how some of these shapes work together and fit together. But thus far, I really haven't had much of a need to pop that box open. So we're going to be selecting edges so we can chamfer them. I think we may want to get rid of some of our extra vertices by doing some target welding first. But we're going to have all these edges selected anyway. And if you're going to chamfer, let's not do it in don't do it in perspective view, because it doesn't want to. These kind of tools apparently they really don't work and play well with perspective view. If you want to change that to orthographic view or any of the orthographic views, front, top, side, this kind of tool works much better. So we're going to go ahead and chamfer that. And when we accept it, we're going to transfer that middle edge. One thing you want to check if you're using 3ds Max, it has a little feature down at the bottom. It's the first row from the bottom, middle button, and you can select. You can tell it to smooth the entire model or just smooth the thing that you worked on, the result that you got, and just smooth the result. That's the choice you want to make. And it has a tool tip. It'll tell you before you commit. But if you if you find yourself using a chamfer tool late in your modeling and you don't make sure that smooth only the result was selected, you're going to be selecting a whole bunch of polygons and giving all of them unique individual smoothing group numbers, because it will just use whatever number it feels like for the entire model. The entire model will have may have a single smoothing group assigned to it. So it's best that you go ahead and make sure every time before you commit to the chamfer that you're only telling it to smooth the result, the chamfered result, and not the entire model. And again, let's not work in perspective mode. Let's work in one of the other orthographic view modes, which would be a lot better. And you can see we have a control here where we can add some tension or take tension out of that. We can make it rounded, more pointy. So we're going to make it more rounded. We just want it to have a nice progressive taper from the base to the top. We don't want that taper inverted. So if the stabilizer is smaller at the bottom than it is at the top, we want the opposite. And what we also want to do here at this point is we would like to select all the polygons in the stabilizer, and we want to give them all a unique smoothing group number. Really prefer choosing that myself as opposed to the program. Of course, we want it to be different than the smoothing group number for the fuselage, so that'll make it nice and crisp. The line from the fuselage to the break from the fuselage to the plane. So here's what it looks like right now. Not bad. It's getting there, right? So now we're going to do a little more work on the top. So we can give that some more curvature. And we want to go ahead and, let's go ahead and be able to see through this. But what we're going to do first is we're going to go ahead and select vertex mode, and we're going to even out using the scale tool. We're going to just zero the value of those in the y-axis. We're going to get those all evened out. Now we can use the chamfer tool and really give this some more curvature. And that's looking a lot better. It's looking a lot less segmented than previously, and I'm thinking we can probably leave it at that as far as how many actual segments we need, because at 1 to 200 feet or so where the virtual camera is going to be, that's going to look great. So I think you noticed that after we accepted that, it gave it gave those polygons a brand new number that we didn't select. We'll come back and fix that. A new smoothing group number that we didn't select. So we'll come back and fix that. So we just selected the trailing edge of the stabilizer, and we use the chamfer tool, and we're creating extra edges so we can get the trailing edge of that stabilizer closer to our reference drawing. And where I moved it, you can see that there's something standing proud of the trailing edge of the stabilizer. That's a trim tab on the real plane. That's a trim tab. It was not adjustable, and you weren't supposed to push on it if you could. But that was just a fixed trim tab, and we will recreate that as one of the details, little details that we'll do once we get the rest of the fuselage sort of sorted out with wing tips and stabilizer tips for the horizontal stabilizer. Right now we're just getting getting the vertical stabilizer close to the shape of our reference drawing. And we're going to go ahead and we're going to do some target welding here. We're going to target weld all our extra vertices and decrease the number of polygons that we have. And decreasing the number of polygons that we have is helpful. It's helpful if you do this more efficiently, because it'll be easier to do the texture mapping. This is where we take this plane and we'll assign material IDs, and we will to each part of it, and we will take each part of the plane designated by its material IDs, and we'll take those polygons and we will flatten them out as if they were trading 3D for 2D at that point, and we'll flatten those out, pretty much like taking all the seams out of a shirt and flattening that material out, laying that material out on a table. It's flat, and so doing that with our 3D object makes it ready to take that map, the map of all the surfaces that we need to paint, and we pull that into Photoshop or GIMP or whatever you like using, and then we can paint it. We can paint a really nice texture for it. Create grunge effects. Dirty up the plane, reflection maps, highlight maps, things like that. Bump maps, normal maps, whatever. But we have to break it down into 2D space first, and we'll get to that. Right now, what we're doing is we're taking the groups of vertices that we created when we chamfered all those edges earlier into a better shape for the top of this stabilizer. We're straightening out those vertices and then rotating them into place, scaling and rotating them into place so that they take on the shape of the stabilizer drawing. Now, again, this it doesn't have to be exact. Where we can go with close. Close is great. There's more than one way to accomplish this, straightening things out. Here, if you want, you could use a cut tool and cut a nice straight edge into it, and you could target weld it just like this, and you'll have a nice straight edge, to work with. One's as easy as another. You might come up with an alternative way that we haven't talked about or seen here. And you do whatever works for you. I mean, I've been, working at this off and on for, I guess, around 10 years, and I still don't have everything figured out, and I'm still learning, and that's what makes it fun. You create a new project for yourself, and you find there's always something to learn. You find one thing or another to learn about, when you're doing this, and hopefully these tutorials they help you out. Because there weren't a whole lot of them when I started trying to learn how to do this, so I just kind of wanted to pass a little bit of what I've learned over a few years on to you guys, and hopefully it helps. So again, we're just scaling and rotating and straightening and making our vertices and our edges conform to the appropriate angles where our curves are in our the base of our horizontal or vertical stabilizer rather. Not hard, certainly, but a little tedious, but that's okay. It gives us something to do, and it's kind of fun. You start out from this cylinder primitive, and from that cylinder primitive, we're creating a plane, and we're not just creating a plane, but we're doing it all in one piece. So, if you were so inclined, you could take the resulting model after we're finished and convert that to an object that were suitable possibly for 3D printing, let's say. And you could give that file to a 3D printer, and they could print a scale model, like a desktop model of your 3D model, which you could paint and display if you were so inclined. So that's kind of one of the cool things. It doesn't necessarily have to be for print art or some kind of coffee mug or a product or something like that. You could create your own 3D models, for display, if you like. So not quite 1,001 uses, but still, I mean, it's rewarding, I suppose, in some sense that you're creating, you're making a very complex object out of a very simple one. So now we're going to make the horizontal stabilizers. So we're going to use a spline again. We're going to use shape merge again. We're going to use the edit poly modifier, and we're going to extrude again. So let's use the spline that we used for our wing root, and let's move that back to our horizontal stabilizer. I didn't see any reason why we couldn't use the same spline. I don't have the airfoil sections, so I have no idea whether it's just a scaled down version of the airfoil section or not. I really don't have any idea. Is it important? Not really. It's not an engineering model. So you want it to look right. You want it to look nice, and it's going to, And if there's somebody out there that lays their hands on the on the the airfoil sections, and wants to do sectional layup and a model that way, that's fantastic. I think that's great because you really do get a really high degree of fidelity and detail when you start doing things that way. I just choose not to. I tend to look at something like this more like sculpting, I guess, in 3D, and so this is just the way I've chosen to do it. This is the way I chose to learn how to do it. Now, I could do, I do have some plans, blueprints, if you will, that are in sections where you could do a like a sectional drawing that you would use to like normally used to create a wooden desktop model, in contours, and you would have to sand everything down and make it that way. You can do the same thing in 3D, which is what I was talking about earlier. I just choose to, do this more like an exercise in sculpting, which is kind of what it is. So right now we're just getting the shape of this airfoil a little closer to what's in the drawing. We're also going to go back to the fuselage, and we're going to cut and do some target welding here so we can get, there's an edge that's really close to the leading edge of our stabilizer root, and I want to get rid of that. I want to move that, because when we do the shape merge, it's going to create a little bit. It's probably going to create a little bit of a problem with edging, or edges rather, right there. So we're going to do something about it preemptively, and we're going to get rid of that edge by moving it, and we can move it by cutting new edges and then doing some target welds. I think we're probably going to do one more. And we're going to weld it to that vertex right there. There we go. Just want to move that out of the way, because they're going to end up being 3 or 4 vertexes with edges going in a couple of different directions once that shape merge happens, and the edges for that stabilizer root are cut into the stabilizer there. So now we're going to go to shape merge, and we're going to pick that, and it has been cut into our fuselage, and we are going to go down and we are going to select edit poly, and first things first, we're going to weld up or target weld our extra vertices. Why it does this, I don't have any idea. It just does, and it can somewhat be controlled by where you put your spline to be shape merged on your object, and where it hits over the existing edges on the object. So we selected polygon, and this is what we have resulting from our shape merge. So we're going to extrude it now, extruding it away from the fuselage. And that's really as far as we need to extrude it. Now we're going to take that edge, and we're going to move that, and we can move that to the root of the tip of the stabilizer. Almost said wingtip. It is kind of a wing. It is a wing. We just call it a stabilizer. I'm going to assign that its own unique smoothing group number, and we're going to go ahead and make that planar to the x-axis, and I'm going to scale that a little bit. I think we've already got it at the correct angle for that stabilizer. We may want to scale it in the y-axis if we're looking at it, you know, straight forward, which we did. And now we're going to go ahead and cut edges from top to bottom for each vertex along the end of that stabilizer. And this, my friends, is where we are going to leave it for this week. And we got a lot of work done this week. You made an intake, you made an exhaust, you made the wings, the vertical stabilizer, and the horizontal stabilizer. Next week we can come back and do the wing tips and the stabilizer tips. So please do me a favor, subscribe and like. Thank you for sticking around this long. If you liked it, please hit the like button and subscribe. If you didn't like it, thanks for sticking around this long. Please look at the links that I've included in the video description, and above all, have a great evening.